Ever find yourself watching like a high-speed train just zip by, and you just kind of wonder, like, how does it even stay on the tracks at that speed?
Right.
It's incredible.
Yeah.
We all picture those classic train tracks, right?
Yeah.
With the wooden ties and the gravel.
Right, ballasted track.
Yeah.
Yeah, the system that's been around, what, for centuries? And you know what?
What's that?
It works. It's
Yeah.
simple, reliable, and surprisingly resilient.
Okay, resilient. But I was reading that this simple system needs maintenance every 3 to 5 years and a full ballast replacement every 15 to 30 years.
Yeah.
That's a lot of upkeep for something that seems so straightforward.
It's true. That's the thing about ballast and track. Its simplicity is also its Achilles heel. So as train speeds increase, so does the wear and tear on that ballast.
Of course.
You've got crews working around the clock, often at night, to keep those tracks in top shape.
Oh, wow.
It's a massive logistical dance, especially with today's demand for high-speed rail.
Yeah, and that leads us into, I think, the world of slab track,
Yes,
which is almost like the high-tech cousin of ballasted track, right?
it is, yeah.
Instead of gravel, we're talking concrete slabs. Can you imagine the difference in maintenance?
Oh, absolutely, yeah. Imagine this. Slab track can last 50 to 60 years with minimal upkeep. We're talking double, sometimes even triple, the lifespan of ballasted track.
Wow, that's incredible. Not only are we talking about a smoother ride, but the long-term cost savings on maintenance must be enormous.
Huge.
So why isn't slab track everywhere? What's the catch?
Well, like anything else, it's a trade-off. While slab track excels in the long run, the initial construction costs can be significantly higher. In some cases, you're looking at double the upfront investment compared to ballasted track.
Double the cost. I guess you really have to weigh those long-term benefits against that initial sticker shock.
You do.
I'm curious, though, our notes mention that this cost difference varies quite a bit depending on, like, the location.
Yeah.
Why is that?
You've hit on a crucial point. It's not just about choosing slab track or ballasted track. It's about choosing the right type of slab track.
Okay.
And that's where things get really interesting.
Different types of slab track.
Yeah.
I had no idea. I thought it was just concrete slabs and you're good to go.
Right?
Tell me more.
It's a whole world of engineering. You've got your Rheda technique, common in Germany, where they embed sleepers in a concrete trough.
Okay.
Then there's the Züblin technique, also big in Germany, where sleepers are embedded directly into a single slab of concrete. And then...
Hold on. Sleepers, troughs, it's like you're speaking another language.
Oh, right.
Can you back up and like explain what those are?
You bet. Imagine those classic wooden ties you see on traditional tracks. Those are your sleepers. They provide a bed for the rails and help distribute the weight.
Okay.
In some slab track systems, like the Rheda method, these sleepers are nestled inside a concrete trough, which is basically a precast concrete channel that acts as a base. The Züblin method, on the other hand, skips the trough and goes straight for a solid concrete slab with the sleepers embedded right in.
Okay, so different techniques, different ways of embedding the sleepers.
Exactly.
It's starting to make sense. And those are just the German methods.
Right.
I feel like there's a whole world of concrete out there I'm just discovering.
Oh, absolutely. Don't forget the Stedef technique, commonly used in tunnels.
Right.
It's got this cool feature where they add a layer of rubber between the sleepers and the concrete slab for extra cushioning and noise reduction.
Oh, wow.
Imagine zipping through the tunnel on that. Smooth and quiet.
I can see why that would be important in a tunnel.
Yeah.
And speaking of smooth and quiet, I read that Japan takes a totally different approach with their high-speed Shinkansen lines. No sleepers at all.
I know.
The rails are literally fixed directly onto those concrete slabs.
Exactly. It's a testament to how far slab track technology has come and how it can be adapted for very specific needs.
Yep.
But no matter the type of slab track, one thing remains constant. The need for meticulous design and engineering, especially when you're talking about high-speed trains.
And that brings us to the fascinating world of computer simulations, right?
Yes.
I read that engineers use something called the finite element method to make sure these tracks can handle the immense forces involved.
It's true. FEM, as it's called, is like a virtual crash test for train tracks.
Oh, wow.
Engineers use it to create incredibly detailed computer models of the track and then simulate the stresses and strains it would experience under different conditions, like high speeds and heavy loads.
So it's like they're putting the track through its paces in a virtual world before they even lay down the first slab of concrete.
Exactly. This helps them optimize the design, identify potential weak points, and ensure the long-term stability of the track, which is crucial with slab track because of something called differential settlement.
Differential settlement. Okay, you lost me again.
Okay. Think of it like this. Even the most solid ground can shift and settle over time, especially under the weight of trains.
Right.
Differential settlement happens when different parts of the track settle unevenly, which can lead to bumps, dips, and, in the worst cases, even derailments.
So how do they prevent that? That sounds like a recipe for disaster.
That's where a strong and stable subgrade comes in.
Okay.
The subgrade is the foundation beneath the track, and it's absolutely critical for the success of any track system, but especially slab track.
Of course.
Engineers go to great lengths to ensure that subgrade is as solid and consistent as possible.
So it's like building a house. You need a strong foundation to support everything else.
Exactly. And just like with a house, there are different ways to build that foundation depending on the soil conditions, the weight it needs to support, and other factors.
Okay, so we've talked about ballasted track, the different types of slab track, the importance of computer simulations, and the critical role of the subgrade. It's clear that each system has its own strengths and weaknesses. But at the end of the day, is one objectively better than the other?
That's the million-dollar question, isn't it? And the answer, as with most things in engineering, is it depends.
It depends, huh? So it's not as simple as saying slab track is the future, goodbye ballast.
Not at all. Think of it like this.
Okay.
You wouldn't use a hammer to tighten a screw.
Okay, bad analogy for me. I'm all thumbs.
Right.
But I get your point.
You choose the best tool for the job. Slab track is fantastic for high-speed lines, tunnels, and places with stable geology. It gives you that smooth ride, longer lifespan, and lower maintenance. But for many other lines, ballasted track is still the most practical and cost-effective solution.
It's all about finding that balance between performance, cost, and the specific needs of the railway.
Right.
Yeah.
Exactly. And we can't forget the incredible engineering that goes into both systems. I mean, we talked about replacing ballasted track every 15 to 30 years, but slab track is designed to last 50 to 60 years. Can you imagine the logistical puzzle of replacing something that's essentially a giant concrete slab?
That blows my mind. It's not like you can just shut down a high-speed line for a month while you rip up and replace miles of track. So how do they even begin to tackle a project like that?
Well, they have to get creative. Sometimes they use precast concrete sections, kind of like giant Lego blocks, to speed up the process. Other times, they've developed techniques to replace sections of the track while trains are still running on adjacent tracks.
Seriously. That's some next-level engineering. It makes you appreciate all the hidden complexity behind something we usually take for granted.
Absolutely. The next time you're on a train, whether it's zipping along at high speed or just your average commuter rail, take a moment to think about what's happening beneath those wheels. It's a testament to human ingenuity.
And to those incredible maintenance crews working tirelessly behind the scenes. So we've talked about the lifespan of these systems, the replacement challenges, but what about their end of life? We can't just leave massive chunks of concrete scattered across the countryside after they've served their purpose, right?
That's a great question, and one that highlights the growing focus on sustainability in railway engineering. Remember, one of the initial drivers for slab track was reducing all that waste from frequent ballast replacement. Now we're facing a new kind of waste, but thankfully there are solutions.
Like what?
Well, for starters, concrete from demolished slab track can be crushed and reused as aggregate. That's the chunky stuff in new construction projects like roads and buildings.
Oh, so it's not going to waste, just being given a new life. I like that.
Exactly. And researchers are constantly working on new types of concrete that are even easier to recycle or have a smaller environmental impact from the get-go.
That's really encouraging. It seems like railway engineering is a field that never sits still, always innovating, always looking for ways to improve.
Couldn't have said it better myself.
This whole deep dive has been a real eye-opener. I mean, who knew train tracks could be so fascinating?
It's a hidden world beneath our feet.
And speaking of hidden worlds, we want to leave you with this final thought. If something as seemingly simple as train tracks has this much complexity and innovation behind it, what other everyday things are hiding their own fascinating stories? What will future train tracks look like as speeds and demands increase?
Now, those are questions worth pondering. It just goes to show there's always more to discover, more to learn, and more to question about the world around us.
And on that note, we'll wrap up our deep dive into the surprisingly complex and constantly evolving world of train tracks. We hope you've enjoyed the journey. Until next time, keep those minds curious. And remember, there's always something new to discover.